My name's Matt Weaver. I work for Headland Machinery, and we're here today to do a live demonstration of the Maxim 1530 abrasive Waterjet system from Omax. To give you a brief bit of background, try and say that after a few more drinks. Omax have been making waterjets now since 1992. They are currently the industry leader in abrasive waterjet systems for cutting applications, XY tables such as the one you can see behind me. Headland have been partners now with Omax for 10 years, and Headland are machine innovating enablers, basically. So we supply equipment to the industry to help the Australian manufacturing industry grow and get better. Alright, so anyway, that's a brief introduction as to who we are and what we're about. Let's have a look at the machine. As I said before, this is the Maxim 1530 abrasive waterjet. So 1530 means it's 1.5 meters in the y-axis and then 3 meters in the x-axis. This one you see here has got some options on it, some additional extras. We have the 5-axis cutting system. This allows you to do beveling, countersinks, well prep edges, that kind of thing. We also have at the back the rapid raise and lower tank. The rapid raise and lower tank is a fantastic feature for being able to raise the water in your bed quickly, submerge the cutting area, which means you get quieter and cleaner cutting. You'll see all this later when we actually do a cut. In addition to that, we have the Enduramax pump on this one. This is Omax's premium pump. It has up to 800 hours of maintenance life between your required seal changes and runs at 60,000 psi. So fantastic pump. It's the latest innovation in pump technology from Omax. So again, we'll take you through that in a bit more detail in a minute. Alright, so if you've got any questions through any of this, please feel free to type in the comment section below, and I'll do my best to answer them. Okay, so let's take you through some features unique about a Maxim or an Omax waterjet. One of the first things I want to show you is the drive system. This is called the Intellitrax Drive system. So what that is a traction drive system. Now, other bits of equipment out there, other waterjet manufacturers use traditional motion technologies such as rack and pinion, drive belts, that kind of thing. Omax have developed the Intellitrax Drive system, so it's a traction drive like I said before. Now what that means is there's no mechanical interface. So with no mechanical interface you get very, very little wear, you get no backlash on your system at all, which means you get continuous accurate cutting that doesn't wear over time. Alright, so what we're going to do is we're going to take a quick walk around to the back of the machine where I've taken one of these covers off. You can actually see the drive system. So follow me. Okay, so as you can see here, we have a drive rail on the x-axis. This here is a hard stop to stop the bridge from rolling off the end, obviously. We have a drive rail. Now, on this drive rail, there is a contact wheel on the underside, which is just tucked underneath there, we can't quite see it, and there's a pinch roller on the top. Now, what this allows the system to do is that when the drive isn't engaged, it just rolls up and down freely. It's very, very low forces, very, very free running, therefore doesn't require much power to run it. Now, one of the great things about the Intellitrax drive system is that it's the only drive system that's been specifically designed for abrasive jet cutting. Now, what does that mean, you might ask? So, all the other drive systems out there, your rack and pinion, your belt drive, ball screws even to a degree, have wear components. If abrasive gets in there, it's going to cause you problems. Now, this is an abrasive environment, so with all the best wood in the world, the abrasive's going to get in there. So therefore, it's going to wear these components down, it's going to cause problems in the future. With the Intellitrax drive system, you don't have any of that. It can run quite happily with abrasive on the track, it just simply pushes it out the way. The covers are in place to protect the drive rails from any reckless forklift drivers, shall we say, crashing into it, causing any issues. So it's there just to protect it from that kind of thing. It's not there to stop any water or abrasive getting on it. It will function perfectly well without it. It's just purely there to protect it from collisions or anything like that. Okay, so that's the Intellitrax drive system. Incredibly efficient, incredibly accurate. It also has a 1 micron magnetic closed loop encoder system on it as well. So it knows where it is at any time. The fact that the front and the rear of the axis are both driven means that it is constantly monitoring, constantly adjusting itself to make sure that you get the accuracies you need from the parts you're trying to cut. All right. One of the other features I want to show you is this pump. As I said before, this is the Enduramax 40-60 pump, this one actually, not the 50, this is the 40. You can see, nice little wooden top, nice feature. Inside, you'll see it's a direct drive pump. So there's no hydraulics, there's no complicated electronics, nothing like that. It's simply just a crankcase, which is running 3 plungers through into the manifold, and that pushes the water out to the nozzle. So there's nothing complex about it, it's incredibly simple. So as long as that crankcase is turning and it's pushing water, you're generating pressure and you're cutting parts. This has up to 800 hours of seal life on it, so you can run 800 hours before you need to do any maintenance cycles. Very robust, very simple, like I said before. They just run and run and run. Okay, let's go back round to the front of the machine. One of the other real unique features about an Omax Abrasive Waterjet is the software. Now the Omax software suite is called Intellitrax software suite. It's made up of various different components, but the main two are layout and make. Layout is the part where you actually program your parts, and make, which is the one you can see on the screen right now, is the part that actually controls the machine itself. So to help you understand how layout and make work together and how you can use them, I'm just going to show you briefly how it works. I'm going to program a quick part and then we're actually going to cut it. Alright, so as you can see here, this is just a Windows based piece of software. If I minimize the screen, you can see it's just Windows 10, and it's actually just a PC that's running this system. So there's no specialist controller, there's no specialist language that you need to learn to run it. It is purely just a Windows based controller, Windows 10, and it's just a PC. So let's go back to layout. Okay, I'll call up a fresh page. So as you can see, over on the left hand side over here, you have your drawing functions, you have your editing functions, and you have some special features around the edges. This means it operates as a standard CAD system, but you can also import pretty much any file type. You can bring in DXFs, you can bring in DWGs, you can bring in PDFs even, TIFF files, GIF files, bitmaps, anything. If it's an image file you're bringing in, you can use the trace function to generate your DXF from that, or you can just trace it yourself manually if you so desire. I'm just going to draw up a simple pipe flange, for example, right? Just to give you an idea of how quick and easy it is to use. So first thing I obviously need to do is I'm doing a pipe flange, it's circle. So I need to draw a circle. So let's make it 150 millimeter diameter. Next thing I need to do, I need to put a circle in the center. So a circle center. Click on center, let's make that 50 mil. Now, I'm going to need to put circles on a PCD. So again, I need to put my PCD down. So that's another circle. I'll put that at the center of that little one. We'll do that at 125 mil. Next are small holes. We'll make those 10 mil. Now I just need to select that hole there and rotate that around. So let's do 6 of them. There we go. Now I'm just going to get rid of the PCD line because we don't need that. Okay, so as you can see there's your simple pipe flange. The next thing I need to do is assign what's called cut quality information. Now what the quality information is the surface finish that your cut is going to leave behind. So quality 1 is the roughest but the fastest, quality 5 is the smoothest but the slowest. So you'll find the majority of people will do most of their cutting with either quality 2 or quality 3. So I'm going to do this one at quality 3. So that's nice and simple. If I click on there, you can see that all your qualities are different colours, which makes it really, really simple to quickly notice on your drawing what quality all the different features are at. The other thing as well is that not all the features need to be the same quality. So if you want to vary the quality infinitely throughout the part, you can do that. You can have one edge at quality 1, have a hole you need to size at quality 5, so on and so forth. I'm going to do it all at quality 3 for the purpose of what we're doing here. So we go quality all 3. That's now all selected at quality 3. Just need to save it quickly. I think somebody's at the door. Alright, so I've now saved that. I now need to actually make a toolpath. We have a button down the bottom here called Auto Path. I click Auto Path, and as you can see, the traverses and the lead in, lead outs are already done. It's automatically taking care of that for us. You can obviously configure that to suit your requirements. You can go top to bottom, left to right, whatever you want to do. Now we need to actually make our ORD file, which is the actual toolpath data file. Click Post, pick my start point. That has now generated the actual toolpath file itself. So this is the file that Make is actually going to look at. Click Save. So you can see how quickly there I've gone from having absolutely nothing to having a toolpath. So I can now jump over to Make, which is the software that controls the machine and actually does the cutting. I can load that part up. Once I can remember where I saved it. Nope. Just give me a second, everybody. Yep, there we go. I remember now. Okay, so there it is. I can now set my material type and my material thickness, my tool offset, and I can turn the 5-axis system on and off if you have one fitted, obviously. So for the purpose of this one here, I'm going to turn the 5-axis system off. So click OK. That's now doing its working out. So this is another unique feature about the Omax systems, is what we call compute first, move later technology. Okay, so what this has now done, this has already worked out exactly all the commands it's going to send to the drives. Okay, so it knows to the second how long it's going to take to cut this part. So that timing quotation it gives you in there is to the second. Okay, and I challenge anybody to come bring me their part, time it, and you'll see I'm right. Okay, so now what I'm going to do is I'm going to show you how to move the head around. We're going to position the nozzle in a good place to cut this part, and we're actually going to cut it. All right, so to move the head around, it's nice and simple. I just use the arrows on the keyboard here, or I can use the buttons on the screen. Doesn't really matter. So just give me a sec. Okay, so I think that's in a good position to start cutting. I'm just going to bring the head down. So that's now in the start position. Okay, so you'll notice that the material's still out of the water, and I spoke before about making sure that you submerge your part to cut, because it makes it cleaner and quieter. So by using this little lever here, as you can see, it brings the level of the water up to the point where the part and the nozzle tip is submerged. It makes it a lot quieter and a lot cleaner. Okay, so I'm just going to go flick the pump on, and then we'll cut it. Okay, here we go. Okay, you ready? It's a lot louder when you don't have that nozzle submerged. Which is why I think that's a really good feature. Okay, so there you go, it's done. I can reach straight in, pick it up. Completely cold. There's your finished part. As you can see, it's exactly what I drew. And that took 2 minutes to complete. Alright, so from going from having nothing, you could essentially, if I wasn't waffling onto you guys, I could essentially draw this and have this cut in under 5 minutes. Okay, then it's going from absolutely nothing to having a finished part in 5 minutes. You know, you go away, have a cup of coffee, come back and it's done. Okay. One of the things I want to show you. Other unique features about this software, and this is one of the things that I really like about Omax, is the fact that all the software upgrades are free for life. Okay, so there's a really good sample that we take to trade shows with us. We show 3 gears, one really small gear, one medium size, one large. And the only difference between those gears is the software that was used to cut them. They all took the same amount of time to cut. They're 1 inch thick stainless steel gears. And the only thing that changed was the software upgrade. So customers that bought a machine that cut that small gear now have a machine that cuts that big gear in the same amount of time. And that's purely by free upgrades. And that's available to every single Omax customer. Okay, so really good feature. Alright, so now obviously, we're talking about the 5-axis head before. So what I'm going to do now is I'm just going to load up a 5-axis program, and we're actually going to cut something with the 5-axis head, just so you can kind of get an idea of how it moves around and what it does. So same process again. Again, I can pick my material. As you can see, we have lots of different materials available to us here. Plastics, stones, woods, foams, rubbers, all kinds of metals and glass and composites, ceramics even. There's lots and lots and lots to choose from. The piece I've got on is 8mm thick aluminium, so we'll leave that as it is. What I do need to do now is turn on my 5-axis system, so that's now done. Click OK. So that's now loading up, and it's loading up all the movements it needs to do for the 5-axis as well. So I'm just going to traverse the head over again to a good position to start the cut. And I think there looks like a good place. I'm going to bring the water level up again, because again, keep it nice and quiet. There we go. Don't forget guys, if you've got any questions, please feel free to put them in the comments below, and we'll do our best to answer them, alright? Okay, here we go, 5-axis cutting. We've got a little technical issue there. I think our gimbal's just died on us, so just bear with us a second. Yeah, I think we're back on. Excellent. Alright, let's start the 5-axis cutting. side again. Technical issues. Okay, so I'm just going to lower the water level down, just while John reboots our gimbal for us. There we go. First world problems. Okay. Let's reach straight in. Pick the part out. And there you can see what I was cutting. You see the fan blades on that. Okay, pretty good. Nice and simple to do, quick to program, easy to cut out. Alright. Okay, so that's working with the A-Jet. That's the 5-axis part. So what I'm going to do now is I'm just going to answer a few questions that I've had come up at trade shows. These are the common questions we get asked all the time. So the most common one I get asked is regards to cutting pressure. Okay, so other manufacturers will offer you machines that will cut 87,000 psi, 90,000 psi, all these fantastic, lovely big numbers. Okay, but what does it actually mean? People come to me and say, Matt, what's the best one? Do I go for 60,000? Do I go for 90,000? What's going to give me the best results? All right, the answer is reasonably simple. Pressure is not what determines how fast your waterjet will cut. Okay, what determines how fast your waterjet will cut is something called hydraulic horsepower at the nozzle. Essentially, how much water can you move through that nozzle within a given time? The more water you can move, the more abrasive you can move. And as this is an abrasive waterjet, therefore it's the abrasive that's doing the work and doing the cutting, the more abrasive you can move, the faster you're going to cut. So it's not about pressure. To generate those high numbers, those high pressure numbers, you have to restrict the flow of water. By restricting the flow of water, you're reducing your hydraulic horsepower. Therefore, you're actually reducing your cutting power. You're going to be going slower. It's as simple as that. So you see these lovely big numbers, they look fantastic, they actually mean nothing. All it means is you're going to be cutting slower. Alright, so with our Omax direct drive pumps, we have the most efficient pumps on the market, roughly about 89-90% efficiency, which means that 89 to 90% of the electricity that comes out of the wall is actually being turned into cutting power here at the nozzle. Alright, and that kind of efficiency means we can cut faster than anybody else. And I'm more than willing to back that up as well. So if you have a DXF you want to send me to do you a time study, I'll do that, and I'll prove to you that our machine will cut faster than anybody else's. And it's just simply down to being efficient and having the highest hydraulic horsepower at the nozzle out of anybody. On top of that, the cutting model that Omax use is very, very unique. What it does is it really controls and understands the behavior of the jet when it's cutting. Alright, so imagine when you're cutting with a water jet, it's not a fixed tool, it's you know, it moves around. Alright, it's live. So as you're cutting and you're dragging that tool through the material, it bends back. Okay, now if you were to go around a sharp corner at flat out speed, that bend would end up with a big nasty flared end to the bottom. Alright, so you need to control that. So to control that, Omax have worked out how the jet behaves and therefore how to decelerate and accelerate in the corners and the other geometries of the part to allow us to push through.